This owns a small clothes shop in a seaside town. She records the weekly sales figures and the average weekly temperature for 8 weeks during the summer. And the product moment correlation coefficient is large negative, minus 0.915, stating your hypothesis clearly and using a 5% level of significance test whether or not the correlation between the sales figures and the average weekly temperature is negative. This is in the whole population. So H naught, our standard, is going to be that there is no correlation. In H1, that it's negative. So now, yeah, rho is the population product moment correlation coefficient. We're dealing with 5% significance level. N is equal to 8. And now we look up the critical value in the table. We don't have to do calculations for this, it's already been done. So 5% down this column, 8 along this row, and we're going to get 0.6215, or in our case, minus 0.6215. So I'm just going to draw a little probability line. We've got -1, 0, 1. Just found out, there we go, there's our critical value. And ours is even, it's here. So it is well in this critical region. So minus 0.915 is less than minus 0.6215. I'm going to reject H naught. Sufficient evidence at 5% level of negative correlation. Suggest a possible reason for this correlation. So as the temperature is increasing, the weekly sales figures are going down, and it could be that people are just less likely to shop. As temperature increases, people may be less likely to shop, more likely to go to the beach, since we're in a seaside town. This suggests a linear regression model could be used to model these data. So that means if we plot the points, then a straight line would fit it really well. State giving a reason whether or not the correlation coefficient of this minus 0.915 is consistent with Tessa's suggestion. And the answer is yes, because it's close to -1. Don't need to write loads here, just that it's close to 1, so linear. So Tessa is correct. A straight line will fit the data well. State giving a reason which variable would be the explanatory variable. This is also known as the independent variable. It's the one that either we control or is controlled by other external factors, in this case, the sun and the earth and everything. So it's going to be the temperature. And then the other one, the, what is it, the sales figures, they're likely to depend on it. So they would be the dependent variable, or sometimes also known as the response variable. Tessa calculated the linear regression equation as this. Give an interpretation of the gradient. So what does that minus 171 actually mean? So we could write it as minus 171 over 1. And then for a rise in temperature, of 1 degree Celsius, the sales for the week will drop by £171 on average. We're done. Well done.